Okay, so we were learning about the probable error in the previous class. Okay, and we started with this first problem to understand the probable error. Okay, so here they have given us the value of correlation coefficient, that is R, and then the value of n, that is the number of data that is available. So we are supposed to find the probable error of coefficient of correlation, and we have to determine the limits. What is the upper limit and the lower limit in which the data can vary or the results can change? So if you observe here, we are giving them some range or some limit that the result can change between these values only. Okay, so that is what is called as probable error. There is a formula which is already defined for probable error, that is nothing but PE is equal to 0.6745 into 1 minus R square by square root of capital N. Don't use small n here, it should be square root of capital N. Okay, so if you apply that here, 0.6745 is the constant. This number will not change. So 0.6745 into 1 minus R is 0.6. So 0.6 square by square root of 64, which is equal to, in the next step, 0.6745 into 1 minus 0.6 square is 0.36 divided by square root of 64 is 8, and then 0.6745 into 1 minus 0.36 will give you 0.64. Fine, divided by 8. Now if you divide this 0.64 by 8, you will get 0.08, and when you multiply that with 0.6745, you will end up with a probable error of 0.05396. Okay, 0.05396. Now this is the probable error value that we have got. They have also asked us to find the limits for the population correlation coefficient. So how do we find that limit? So firstly, we will add the value of R as well as probable error. That will become the upper limit. So maximum, the result can be 0.65396, and onto the lower limit, I will subtract R and probable error, where I will get the different result. Okay, so these are something like, say for example, your traffic rules. So they will say in few roads you cannot exceed the speed limit of 40. In few roads you cannot exceed the speed limit of 80. Okay, but in highways you can cross 100. Fine. So that is the upper limit and the lower limit of the speed on the roads. Even in your nice road also, there are certain places where they mention it very clearly, saying you should not go above the speed, or you should not cross the speed of 60 kilometers. Right? So similarly, how do they arrive at all that? These probable error, correlation, regression, all of them are used in many places practically to do the research and find the result. So if at all my result on the lower limit is 0.54 and on the upper limit is 0.65, which means I will be able to arrive at some good result if the numbers are between this. If the numbers are not between this, then it is a problem. Then I have to check what is to be done. Okay, so first, for determining limits, we consider correlation coefficient plus the probable error. Onto the other side, we will again consider correlation coefficient minus the probable error. So here the limits will be 0.6 plus 0.05396. That will give me 0.65396. and on the other side 0.6 minus 0.05396 will give me 0.54604. Now here if you see in the probable error you have got more than 4 decimals. So please be careful while solving these problems because decimals also matters a lot here. Do not round off any number. Okay, consider the decimals. Did you all understand this probable error problem? How to define the limits? This can be asked for 2 marks and 6 marks questions. 2 marks they can ask this question. If R is equal to 0.6, N is 64, find the probable error. At least until probable error they can ask you for 2 marks. Okay. Now moving on to the next problem. These are also same probable error only. Okay. One more thing which you'll have to understand under probable error are, see the last 2 lines here. So we will define the limits R plus PE and R minus PE. After that, if the value of R is more than 6 times the probable error, the existence of correlation is certain. The value of R is significant. Okay. So if the value of R is more than 6 times the probable error. So let us take for example. Now if you consider this problem, the value of PE is 0.05396, correct? Now what are they saying? If the value of R is more than the 6 times, so value of R should be more than 6 times of PE. Okay, more than 6 times of PE means let us multiply this PE into 6. Let us see what is the value we get. Calculate and say me the value. 0.05396 into 6. How much do I get? How much do I get here? 0.05396 multiplied by 6. 0. Quickly. Say me the answer. 0.32376. Now, this 0.32376 is less than 0.6. Yeah, correct. Okay, 0.6 is more and 0.232 is less. Correct? Which means that R is significant. Okay, how did I come to the conclusion R is significant? I'll repeat it again. Listen carefully. This can be asked in your examination because there are questions in the question paper which are asking such questions. Okay, find out if R is significant. How do you find if R is significant? Find out the probable error. Okay, multiply that probable error with 6. Okay, whatever answer you get, okay, this answer compare it with the R value. Now when you compare this with the R value, the value of R should be more. The value of R should be more. Like how you see here, 0.6 is more than 0.32. Correct? So if value of R is more, then R is significant. If value of R is less, then it means R is not significant. Now, if R is not significant, It means there is no use of using R for the further calculation. You will not get the proper result. Are you all able to follow? Yes? Is everyone able to understand? Okay. In this problem, they have not asked if R is significant or not, but there will be questions where they'll ask R is significant or not. Okay. Now let us go to the next problem and see what they have asked us. Okay. To study a correlation between the weights and heights of students of a school, a sample of 100 students is taken from the entire school. Okay, so they wanted to study the height and weight of the students in a school. So they have come and taken 100 students sample from the whole school. Now the sample gave coefficient of correlation as 0.826. So what are they trying to say? The value of R is nothing but 0.826. Then within what limits does it hold good for the entire school? Read the question once again. Within what limits? We are supposed to find the limits. Within what limits does it hold good for the entire school? So there are 100 students in the school. This will become capital N, and the coefficient of correlation found was 0.826. We are expected to calculate the limits which holds good for the entire school. Okay, so to find limits for the entire school, first thing you have to calculate is the probable error. Okay, so the first thing you have to calculate is probable error. Now, if you calculate probable error, you will be able to also calculate the limits that is required to hold good for the entire school. Fine. Did you all understand the question? What is to be found out? Yes? Okay. So, we will find out the probable error. Write the formula. These are very, very easy questions, but subject to condition, you have to understand the question. Okay, 0.6745 into 1 minus r square divided by square root of n. Okay, 1 minus r square is equal divided by square root of n. So 0.6745 into 1 minus r square is already given to us 0.826. So 0.826 square divided by square root of 100. Then 0.6745 into 1 minus 0.826, if you take square, how do you square? 0.826 into 0.826. This is the multiplication. So if you multiply like this, you get 0.6823 whole divided by square root of 100 is nothing but 10. Okay, now further simplify that. 0.6745 into 1 minus 0.6823 is nothing but 0.3177 divided by, sorry, this is actually 10. I don't know why they've taken it as 8. So this is 10 divided by 10. So what will happen if you divide this by 10? You will have 0.03. Okay, one position will go to next. So 0.03177, and this will remain as it is. Now if you multiply these two numbers, you are going to get the probable error of 0.02143. Now they have asked us to find the limits at which the school will hold good. So what are the limits that we will consider? R plus E and R minus E. Right? So R is nothing but correlation coefficient, that is 0.826. 0.826. So R minus PE. PE is probable error 0.02143, and then R plus PE is 0.826 plus 0.02143. This is the second part. Now, if you simplify here, the lower limit is going to be 0.80457 and the other limit 0.84743. Okay, this is going to be the other limit. So now we have got for the entire can you all hear me? So we found out R minus PE and R plus PE. So for the entire school, the correlation coefficient should fall between 0.80457 and 0.84743. So these are the limits where the correlation coefficient should fall. So if it falls anywhere to the other side, then it means that you will not be getting the complete value and the required results. Are you all able to follow? Okay. Now let us go to the next question. Very easy questions. Probable error questions mostly will come for 2 marks or 6 marks. You can find them in the first main only for 2 marks question. So let us see this question. Given PE is 0.039 and R is 0.65 and we are supposed to find the value of N. Right? So here they have given us 2 data and there is 1 unknown data to be found out. So PE is 0.6745 into 1 minus R square by square root of N. So you should be careful in remembering the formulas and understand what sort of formulas should be used in different places. So 0.6745 into 1 minus R square by square root of N. R we know 0.65. PE also we know 0.039. Now let us find N. So there's a constant 0.6745. So 0.039 is equal to 0.6745 into 1 minus 0.65 square whole divided by square root of N. Okay, now here if you see 0.6745 into, there is a multiplication relation here. So if I take this number to the other side, if it is multiplication here, it is going to become division. So 0.039 divided by 0.6745 is equal to 1 minus 0.65 square is 0.4225 whole divided by square root of N. Now slowly one after the other expressions, take it on to the other side. So you are left out with square root of N and it is easy to find the value of N. That is what we are trying to do. So first we took this constant 0.6745 to the other side where it became division and the value after division is 0.05782. Okay, and then to your right hand side we simplified 1 minus this 0.65 square and the total you get is 0.5775 whole divided by square root of N. Now what we will do, instead of taking any number, we will take the square root of N to the other side. We are just exchanging the values here. This 0.05782 will come down and square root of N will go up. So square root of n is equal to 0.5775 divided by 0.05782. Okay. Now square root of n is equal to, here you will get 0.5775 by 0.05782. If you divide this, you get 9.99. Okay. So 9.99 is the value that you get. Now, if it is square root on one side, and if you take the square root to the other side, it is going to become square. Okay. So, if you have square root of x here on one side, and if you take it to the other side, it is supposed to become y square. Clear? That's what we are doing. So, square root taken on to the other side will become 9.99 square. So, 9.99 into 9.99, you get 99.8. This is the value you get. 99.8. Now here, if you round this off, why am I rounding? Because after decimal, the value is more than 5. So if you round it off, you get 100. Okay. So in this place, here, while finding out n, in the last step, we round it off so that we get a complete value of 100 for n. Understood? So that is how you find n whenever they have given you probable error and the value of r. Did you all understand? Yes, everyone understood? Good. Now, let us check here the next problem. Find probable error when the correlation coefficient is 0.75 and number of pairs of items is 36. Interpret R. They have clearly asked us to interpret R. Interpret R means we have to either say if R is significant or if R is not significant. That is what they mean by saying interpret R. Okay. So what all is given to us? Let's read the question once again. Find probable error. We have to find probable error when correlation coefficient, that is nothing but R, is equal to 0.75 and number of pairs of items, that is capital N, is equal to 36. They have given us all the data. So let us solve. What is the formula? Probable error is equal to 0.6745 into 1 minus 1 minus r square by square root of n. P is equal to 0.6745 into 1 minus r square is nothing but 0.75 square whole divided by square root of 36. Value of n is 36. Then if you find the square, you will get 0.5625, and if you find the square root of 36, you will get it as 6. Next step, 1 minus 0.5625, find out the value, and then 0.4375 by 6, you will get 0.07292. Okay. Now, after this, multiply 0.6745 into 0.07292. This is going to give you the probable error answer, that is 0.04918. So now everybody knows how to find the probable error here. But the important step for us after this is interpretation of R. Now, as I already told, if the value of probable error, if you multiply this value into 6, you will get a value. If R is greater than that value, it means that R is significant. So let us interpret the R. Interpretation of R is nothing but 6 into the probable error. So if you multiply 6 into this number, you are gonna get 0.2951. That is what you have got here. Okay. Now compare this 0.2951 and your correlation coefficient 0.75. Which is greater? 0.29 is greater, 0.75 is greater. Which is greater? Say me the value. .75 is greater. If 0.75 is greater, then R is significant. Okay. If R value is greater, then R is significant. Okay. If R value, if at all it is less, then R is not significant. So since R 0.75 is greater than 6 PE, that is 2951, therefore R is significant. Understood? Everybody understood this problem? Any doubts? Any place you want me to repeat it once again? Shall we go to the next problem then? Okay. Now moving on to the next problem. The following data relates to the percentage of failures in 10th standard examination. Read the question slowly, carefully. Fine. The following data relates to the percentage of failures in the 10th standard examination. They have given the age of the candidates and they have given the percentage of failures. So 13, at the age of 13, there were 39 failures, 14, 20 failures, 15, 16 until 21. And here the percentage of failures are given. Now what are they asking us to find? Find whether there is any correlation between age and failure in the examination and interpret the result by finding the probable error. So in this question, you are supposed to find the value of R. Okay, we are only supposed to find the value of R. After finding the value of R, you should find the value of probable error. And then you are supposed to interpret the result. We have to find out if R is significant or not. Did you all understand the question? They have given us the full data of percentage of failures in 10th standard. We have to find out if there is any relationship between the age of the candidates and the percentage of failures. And once we find the correlation coefficient, then we should find the probable error and interpret the result. Okay, so let us start with the table calculation. Give the heading computation of Karl Pearson's correlation coefficient. Now before I start the table, any doubts in the question? You should at least understand what is to be solved. Any doubts in the question? Reply fast. I want everyone to reply. Okay. Now, copy down the value of x from the question. Copy down the value of y also from the question. Okay. So they have given us the value of x and y directly. So what will be the value of x? Value of x is candidates age and value of y is percentage of failures. Okay. Then we are using assumed mean method. We are using assumed mean method. So we are assuming 17 here as the assumed mean for x and 43 here as the assumed mean for y. You can do by using actual mean. Okay. Just make sure the value of x bar should not be in fractions. Fine. So if not, you can use the assumed mean method directly. So in assumed mean method, you're supposed to find the deviations. That is nothing but dx is equal to x minus a. Here x minus a is the value of 17. So x minus 17. So we'll find the values saying 13 minus 17 is minus 4. 14 minus 17 is minus 3. 15 minus 17 is minus 2. 16 minus 17 is minus 1. 17 minus 17 is 0, and so on. We are going to find the values. Now after this, find the deviations for y, that is dy is equal to y minus a. Here we have considered a to be 43. Okay, we have considered a to be 43. So y minus 43, that is 39 minus 43 is minus 4. 40 minus 43 is minus 3. Then 43 minus 43 is 0. And so on. We have to find all the values of deviations from y. Then square the deviations, dx square and dy square, square the deviations. Then you will have dx and dy. So dx into dy. Okay. So dx into dy if you get, then you have to find all the totals of these values. Sigma dx is equal to 0, sigma dy is equal to minus 9, sigma dx square is equal to 60, sigma dy square is equal to 293, and sigma dx dy is equal to minus 88. These are the 5 important values that we require to solve the problem, that is correlation coefficient. Now once we are done with the table calculation, let us go to the formula calculation. Now in formula, R is equal to, formula is very important for every problem as I already told you. R is equal to n into sigma dx and sigma dx into dy minus sigma dx into sigma dy whole divided by square root of n into sigma dx square minus dx whole square root of n into sigma dy square minus sigma dy whole square. So this is the whole value that we have got. Now substitute the values for all of them. N is nothing but 9. How did I get 9? You have the data 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So N is equal to 9 and sigma dx dy is 88 minus sigma dx is 0, sigma dy is minus 9. Then whole completely divided by square root of 9 into sigma dx square is 60, sigma dx whole square is 0. So 0 square. Then again n into, that is 9 into sigma dy square is 293 minus sigma dy is minus 9 whole square. Then if you simplify this in the numerator, you get 792. And in the denominator, first multiply 9 into 60 and then find the square here and then do the subtraction. Do it stepwise so that you don't get confused. Don't do the simplification at a time. Show each step very clearly so that you get full marks for such problems. And it is easy to score full marks for such problems. So once you simplify all of these values, the value of R is going to be 0.6741. So this will be the value of R. Then they have asked us to find out the probable error value also. Okay. Now before finding the probable error value, let us do the analysis of this R like how we were doing before using the timeline. Now, if you use the timeline, this is +1, this is -1, and we have 0. Now, for semi, is this a positive correlation or a negative correlation? Quickly, is this a positive correlation or a negative correlation? Positive correlation? Right? And the value of the R is 0.67. So which means it is going to come in between 0.25 and 0.75, which means which degree of correlation is this? Is this low, medium, or sorry, moderate or high? What is that P, Divyashree? What are you trying to say? It comes in the moderate degree of correlation. So everybody understood how to analyze it. Positive. Okay.